Hey, hi. Welcome to another session, and today we will be discussing about a very important concept of trigonometry. Today what we are going to talk about is having the impact on our daily lives. So far whatever we have discussed is only the theoretical part, and today we have come into a session where we will talk about practical examples. So listen to me very carefully. If you listen to me, I can tell you that you will never forget for a very long time. So let's start. Where does the world's largest sundial exist? It is this place called Jaipur, Rajasthan. The Jantar Mantar in Jaipur, Rajasthan has the largest sundial. Now you will be wondering, why am I talking about sundial? Am I talking about a general knowledge class, or is this a trigonometry class? Just wait for a few seconds and we will discuss about this sundial and how it is linked to our height and distance in trigonometry concept. Look at the diagram carefully. The sundial has a semicircle base, and in the middle there is a straight concrete structure. Now we will put it in a pictorial form, in a very simplified form. Semicircle I have represented, and then I have represented the middle portion as a straight line. Now look at this. When the sun is at the morning, then you will see that the shadow of the middle will be on the opposite side, that is on the west side. Now as the sun travels towards the middle of the sky, so that means you are going towards the noon time. So from morning 6 o'clock you are going towards the 12 o'clock, right? So as the sun rises, you will see that the shadow actually is decreasing. See that the shadow is decreasing. And then when you exactly it is on the top of that middle structure, then you will see the shadow is absolutely vanished. And then comes the afternoon session. Then sun actually travels to the west, and then the shadow slowly will fall on the eastern side of it, which is nothing but the opposite side of the sun. So then you will see that the shadow is slowly increasing, and the shadow is, if you exactly draw a line which is sun, then the tip of the pillar, and then you will drag that line to the where that semicircle base will be touched, you will see exactly that is the length where the shadow will end. So you will see that as the afternoon progresses, that means we are going towards the sunset time, so you will see the longest shadow. Based on the timing, the position of the sun changes, and therefore your shadow changes. And this principle is called height and distance. There was one scientist named Samanta. His original name was Samanta Chandrasekhar. Later his name was given as Pathani Samanta. He has devised a tool, and that tool is made up of what? Guess what? And it is just a bamboo stick, hollow bamboo stick. With the use of hollow bamboo stick and with the principle of this height and distance, he was able to measure the distance between celestial bodies. So great scientist, and he has really applied the principle of trigonometry to measure those distances between the astronomical bodies. It's very fantastic, right? Such a beautiful principle, and it has a lot of wider applications. Another example, beautiful example, will be your radar technology, like aeroplane, right? If an aeroplane is moving at a certain distance, certain height, Then what is the speed of that aeroplane? That is also measured with the help of your height and distance. So what you are studying now has a very wider applications going forward. So remember this concept very thoroughly, and we are going to do this with examples we will read. So don't move away. Okay, 3 things. In this class, I will teach only 3 things. And based on those 3 things, you will be able to solve all the problems which are related to height and distance. So what are they? First is the line of sight. What is line of sight? So you see here, your eye is here. And you are looking at one object. Let's say we are looking at the tip of the pillar. So pillar is here. And you are looking at tip of the pillar. So that means if you join your eye to the pillar, tip of the pillar, that becomes your line of sight. This one is the line of sight. Okay? The second thing is the angle of elevation. The angle of elevation is the angle between the horizontal line and the line of sight. So, if I draw a horizontal line which is horizontal to my eye, then this angle between the horizontal line and the line of sight will be called as the angle of elevation. Why it is called angle of elevation? Because it is towards the upper side of it. That means the object where I am trying to see, that object is higher than me, right? So that is why we call it the angle of elevation. Elevation means height, upper side, right? Now, the third thing will be angle of depression. This will be the opposite of elevation. Depression means I am looking downwards. So when you look at the downward, let's say something like there is a sea and there is a boat here. So I am looking at the boat. In that case, the angle between the horizontal line and the line of sight, because line of sight will be going downwards now. So this is called the depression. So if I will say theta 1, theta 2, then theta 2 will be the angle of depression. Assume that there is somebody who is sitting here on top of the pillar. Let's say it is a lamp post. So on the lamp post, somebody is, let's say, standing here. The person is standing here. Now, if that person is standing on the top of the lamp post and he is looking at something, some tree, let's say this is a tree. So if he is looking at the tree, then what will be happen to, whether it will be angle of elevation or angle of depression? It will be angle of depression. Where the angle of depression will come? Because the observer is here. The observer, the person who is looking at the object, the observer is here and he is looking downwards. So if you take a horizontal line, and this will be the line of sight, right, towards the tip of the tree he is looking at. So that line of sight will make an angle which is downwards. So therefore the angle also will be called as depression. Yeah? In this case, look at this, that this person is looking at to the tip of the lamppost. Similarly, there is another guy who is on the top of the lamppost and looking at down. This is the same another person. So person 1, this is the first person, this is the second person, right? So for the first person, looking at to the tip of the lamppost will become angle of elevation, and for the second person, looking at this first person will become the angle of depression. So therefore, now let's try to figure it out. What is the relationship? Is there any relationship or not? Let's try to figure it out. These two are horizontal lines, and horizontal lines means they are parallel to each other. Now if they are parallel to each other, and this will become transverse line, which is actually intersecting these two lines, horizontal lines, right? So these are alternate angles. So therefore, even this angle and this angle will remain same. So angle of elevation is also equal to the angle of depression. Angle of elevation from one perspective will become angle of depression from the other perspective. This principle you remember, we will also apply this principle in some example. If such type of problem comes in height and distance, always try to draw the diagram. Now, if you draw the diagram accurately, then assume that 50% of the problems are solved. 6 feet height. So this is 6 feet. Yeah, this is the person. You can do a beautiful drawing saying that this person is standing here and he has the height of 6 feet. Is looking at the tip of the tree. There is a tree here. Draw a tree diagram, and the tip of the tree he is looking at. So his line of sight is this, yeah, which is 30 feet away from him. This distance between the tree and the person is 30 feet. Find the height of the tree. It is asking for the height of the tree. This is, you have to find out. If the angle of elevation is 60 degree. Angle of elevation means draw a horizontal line and then take the horizontal line and the line of sight, whatever angle they are creating, that is the angle of elevation, right? Now that is 60 degree. Let's say draw a right angle triangle. So your right angle is this, and assume that this portion is h. So the total height of the tree, if we have to find out, we have to just add this 6 feet, right? So we are just doing a parallel line, and this 6 feet, let's say this is also, obviously it will also become 6 feet, right? So if I take h is the remaining height, then your total height of the tree will be h plus 6 feet. Now, so your answer starts from here, say 6 feet. Now, you see that the angle of elevation is given, right? And this 30 feet is given. This is 30 feet, obviously this will also be 30 feet. Okay? So now, find out h, right? The relationship between h and this 30 feet. What will be the relationship? It will be tan theta relationship we have to apply. Tan theta, if my theta is the angle of elevation, then the relationship, this will become the perpendicular and this will become the base. So the relationship between the perpendicular and the base is defined in tan theta. So tan theta, or say I will say tan 60. What is the value of tan? Is equal to root 3, which is equal to perpendicular by the base. Perpendicular in this case is h by the base is 30, which implies h is equal to 30 root 3. Either you can leave it here, or if you have been given the square root table, value of root 3 is 1.7321. If it has been given, then just multiply by 1.7321 and you will find out it is closely coming to 52 feet. It will come to 52 feet. So this portion is 52 feet and the bottom portion is 6 feet. So the total height of the tree will be h plus 6, which is equal to 52 feet plus 6 feet is 58 feet. So this will be your answer. Hope you would have understood this. I gave you one example and I hope that you would have understood it very thoroughly. If you have not, please mention it in the comment box and we will do some more examples also, like I was explaining, right, how you have to find out the velocity of the aeroplane. So these are problems that have come earlier in the board exams. So I wish you all the best for your studies and your exams. But mind it, always be very, very careful and be very clear on your concepts. If your concepts are clear, nobody is going to stop you. You will 100% solve all the problems if your concepts are very clear. And that is the purpose I am making this channel, that your concepts need to be very clear. I'm here, I'm ready to conduct further sessions on this YouTube channel, provided it helps you to clear your concepts. And that's my only motto. Thank you very much for watching this, and like this video and subscribe to the channel, and you will get the notifications as soon as I will publish another new video. Thank you very much.